make the screen share happen. So this is lesson 10, networking part 2. We're going to go over a review of what we did during the networking lesson, and then we're going to talk about DNS and about some ways that we can tie our app into all this. As a reminder, as I just mentioned before we started the broadcast, if you're not on IRC, you should get onto DevOps Bootcamp on irc.freenode.net. Right here we have an IRC, a client, right here in the channel. So Ken will be pasting stuff during the app portion of the talk, and you will want to see it. So with that, I'm going to hand it over to Erdan to go over a review of the networking concepts that we covered last time.
So my name is Daniel, and I talked about networking a few weeks ago. This is just kind of going to tie a bunch of stuff that I talked about last time together. That is the agenda which Emily mentioned. So last time, if you'll recall, I pointed out that a router that you would have at your house is actually 3 network devices in one, and I've broken them out apart on this diagram. There's the wireless access point, a switch, and a router. And the router is what separates networks. So your home router is actually 3 devices. So these are some of the IPs that would belong to the machines, or if those devices are actually separated out, you have an access point which has its own IP because it's a network device. Can anybody tell me why the switch does not have an IP address? No?
Nope. It's just a bridge, and there's no actual device.
Right, yeah, because it's a layer 2 device. IP addresses are not assigned to, are only assigned to devices that work on the network layer. So has anybody received or purchased a modem that had a router built into it, but you wanted to use your own router, or say your internet service provider provided you with a router, but you would like to use your own because you don't trust their equipment or for whatever reason? So if you've set that up before, then your configuration would look a little something like that. Can anybody tell me what the IP address would be, or what IP addresses are currently missing on this diagram?
The one to the second router.
So where would it be at?
Like, yeah.
Right here?
Yeah.
Okay. And there's 2 that are missing. And you got one of them. The other one is up there. So what would those IPs be if you had to guess? You know that it has to be an IP address of some kind, and you know that it has to be a private IP address. So it could be any private IP address, except for there's only one that it can't be, or one network that it cannot be. Well, that's correct. It couldn't be 0, but it actually has to be an entirely different network. So notice the 2 here is different than all the rest because the /24 separates the host from the network. So you have the network portion ending in a 2 instead of ending in a 1. And yeah.
What are the 2 IP addresses below and next to the top router?
So there's 2 ports on the router.
Okay.
And the one in, there you go. I can use this as a pointing device. So this one is for this interface, whereas this IP would be for this interface. And the reason that they have to have different networks is that fundamentally the purpose of a router is to separate networks. So if you have 2 interfaces, they have to have 2 different networks. Because if your router only had 2 connections and it was to the same network, it can't perform any routing. It only connects to that one single network.
So if it connects to itself, it's not infinite routing?
No, yeah, there's some math that that avoids all that.
So the bottom router would have another one too, right? Between it and the cloud.
Right, correct.
An
Yeah,
external IP.
yeah. It would have an external. It would have a public IP. That's correct. So, and then this, I was hoping that you guys, I have a few hypothetical questions, and then I was hoping that you guys would have some of your own questions as well. So feel free to ask if you have any. So, as you'll notice, all these addresses are /24s, and the IP addresses got cut off from here, but they're the same. So this is a network, that's a network, that's a network, and that's a network. So there's 4 different networks here. And one point of confusion in this diagram, or not in this diagram, but in reality, from a switch, you can trunk multiple networks to a single port on a router. But that router will have, effectively, you can think of it as, since there are 4 connections it's just like 4 cables being plugged in. So if these 2 hosts wanted to communicate, what path would it take?
Has to go all the way out to the router, doesn't it? You can get that.
That's correct, because a switch is a layer 2 device. So even though the switch, even though it could immediately short circuit that and could go back to the router, this network card is on the .2 network, and this one's on the .1. So if it receives traffic from a different network, it doesn't know how to handle that because it only knows how to accept traffic from its own network. The router handles that translation for you. So is that perfectly clear to everybody? Are there any questions that you could think of?
I've heard of smart switches that are supposed to be able to kind of map the traffic and be able to kind of cut out that relationship. Would that work in this situation since there are different networks?
Yes. So it's kind of confusing, so I didn't mention it, but switches have kind of become pseudo layer 3 aware, and so that they could do that. That would still have to respect the difference in the network. So in that case, you'd be using something called VLANs in order for the switch to be able to do that. But that's a whole different area. I mean, that's all the review I had planned, unless anybody has any more questions. Okay. Yeah.
I mean, it's a good sample, but is there, like 192.168 seems kind of arbitrary. Mm-hmm. Is that true? Or?
No, well, so it is arbitrary in the sense that a group of people got together and decided that 192.168 is a private IP address.
Could they have used easier numbers? Or?
Well, if from the binary perspective, it's pretty easy.
Oh.
From the decimal perspective, it's like, why did you do that? But yeah, I mean,
there are other private networks.
Yeah.
Different sizes, basically.
Yeah, and I covered that in the last talk. So yeah, if you there's all those are listed out in the previous slides. So.
10 is pretty easy to remember.
Yeah. 10 is 10.0.0.0 is the easiest, but typically in a home setting you would have 192.168 just because that's what the manufacturers decided. So. All right, well, that's all I got.
Okay, so now for a very high-level overview of DNS, which we will go into more detail on later, and if we end up talking about email. So basically, this is so obvious that you probably think I'm a little bit crazy for putting it up there. I typed the letters, osusl.org, into the search bar, and then I hit enter, and then the OSL homepage shows up. What just happened? Like, did my computer just magically know exactly where to ask for all that content? It used, and also if you don't have your VM up and running, this would be a good time to start it, because then you can follow along with some of these commands. it used the DNS system, the domain name system, to look up, okay, so I have a person who wants this address. It wants whatever lives at osusl.org. So how do where do I go for this? You can use the host utility or the dig utility, but host will give you a shorter answer to tell you what IP address a given site is returned from when you look it up in your browser. So you can run host on a few different sites. If you try it on Google, you'll get some interesting stuff that I'll explain in a minute. So that's what I get. It's 142.11.15.183. Why, yes, as a matter of fact, that is the IP of the server that's hosting osusl.org. There's a little bit more trickery that happens once your request gets to that server, because that server is hosting many sites, not just osusl.org, but Ken will be talking about that, or possibly that'll be next meeting. So the way it knew that that number matches that name is it kind of looked it up in a giant phone book. Is more or less how DNS, is the purpose that DNS serves. DNS runs on port 53. You might need to know that someday. Hint, hint. There are various tests of knowledge that require that. So that doesn't like my images. But basically, DNS models the structure of names on the internet like a tree. You have the root, which is just dot. And then from that root, you have the top-level domains, the orgs, coms, arcas, nets, edus, and all of the country-specific top-level domains and the vanity TLDs that they've been releasing lately. And then, so each of those has a name server that if you ask root, hey, I'm looking for a thing that's a .org, the root will say, here's a name server that handles the .org domains. And then, under each of those, when you register a domain name, like we registered osusl.org, you can have your own DNS server on that domain, and then .org will go, oh, you're looking for one of my .orgs. Let's see, which one? Oh, you wanted osusl. So here, go over there to the osusl server. And then once they're on our DNS server, we can send them to the right server and return the correct IP based on what exactly the request was. So, on a different topic, do some math, pop up a calculator if you have to. What's 15 times 823? Or if you're really, really lazy, I'll give you a minute, I see calculators. If you're really lazy, that's going to be the next bullet point that unveils itself. This will work better if you actually do it.
12,345.
Yeah, 1, 2, 3, 4, 5. Cool number, isn't it? Okay, that was just for fun. You'll see why later. So what I just described to you when explaining how the tree works was this idealized form of recursive DNS. Like, here's how Wikipedia explains itself. First, it'll look at the root, and it'll be like, oh, I need .org, because it's a .org. And then it'll look at the org name server, and that will point you to Wikipedia's name server. And this is guaranteed to always give you a good answer or an error. There are some attacks that work against this that won't work against the next type that we talk about, which is the non-recursive type. This uses a cache or a referral system, so rather than just going back with, here's the IP that you should try for wikipedia.org, it'll give you a referral directly to there. So, next quiz. What's 15 times 823? Exactly, you knew it right away. How did you know so quickly? You cached it. This is exactly what your DNS server will do when it gets the same query over and over, or when it knows to anticipate a given query. So, at nearly any place that handles DNS, it can be cached. This speeds everything up. You can also have what's called negative caching, where you remember not only, oh, I tried to find this thing and here's where I found it, but I tried to find this thing and it couldn't be found. And then the next problem with this is, how long should you remember that for? When you remember the answer to a math question, it's cool to remember it indefinitely because, I mean, that's never going to change, right? But if I asked you, let's say, what's the temperature outside right now? How long, if I ask you what's the temperature right now, you go outside, look it up, come back, and then I ask you again, you're pretty safe giving that same answer. But if we wait for 1 hour, is it likely to have changed? If we wait for a day, how likely is it to have changed? And that value is built into caching systems. It's called time to live, or TTL. It's how long should I assume that this result or this answer is going to be valid for. And that's something that you can manually set when you're setting a record. There are various strategies to this. Generally, if it's something that's likely to change soon, you want to have a shorter time to live. If it's something that's unlikely to change very often, you want it to be cached more aggressively. You'll give it a longer time. So there's also a file inside or in your Linux system that the Berkeley Internet Name Domain tool is bind. You saw bind also when we looked at the man page for host. And this is called a DNS resolver. So when you remember what we said about how the recursive and non-recursive domains, resolvers will need to be non-recursive. There's resolveconf. And so if you look at what you have in yours right now on your VM or on your local system, probably won't have a whole lot in it, but it will have specific name servers that are appropriate for your domain. Yeah, so it's only recursive, no referrals. That's and then yeah.
Never mind. I was going to ask how it's different from the host file.
Oh yeah, and then I'm going to tell you about hosts. So this is where you look for given name servers in a particular domain. And current version is bind 9, so when you see bind 9 at the top of the man pages, you're like, oh, this is what my computer is using to figure out something about how it handles DNS. Yes?
Are we broadcasting?
I think so. We should be. We appear to be. So this brings us to Etsy hosts, which is kind of a DNS thing, but it's actually a workaround to avoid touching the domain name system and name servers at all. Hosts is a file where you just manually tell it, I always want this name to resolve to this IP. I don't care what anybody else thinks. This is great if you're testing a site. You want to point that domain at localhost, for instance, so that you can take screenshots where it looks like you're on the real site or whatever. You'll see this is the hosts file out of one of the VMs that we're using. The reason I didn't use my hosts file from here is that I use a very long one that's linked to from this link right here, someonewhocares.org/hosts, where he basically found all of the malicious names, like places that have annoying ads, places that have shock sites, that kind of thing. And that host file just redirects them to localhost. So this means that when you're browsing the internet and it tries to load an ad, it'll be like mymalware.org/whatever the ad name is. That mymalware.org will try to look itself up in the domain name system, but it will get short-circuited by your hosts file. Your host file will go, oh, mymalware.org actually redirects to localhost, and it'll just return localhost instead. So if you were ambitious and wanted to set up a server, you could have kittens instead of ads. So, yes, Chaos?
When doing that, if you don't have a server set up, do you get like timeout errors?
Yeah, it's just like could not find the site, could not resolve, doesn't work. Yeah?
The kitten thing reminded me of this stopped when we added it in Australia. Have you heard about that?
I did not hear about that.
But replacing a picture of the Prime Minister of Australia with kittens using a browser extension?
Yeah.
Related?
So a browser extension could either note any request going out of the browser and note that request matched a given pattern and change it there, or it's more likely that it'll do that than that it will actually go edit your hosts file, because you need to be root to do that. And I hope that your browser doesn't have root to be editing your hosts file, because think about all the mean, unpleasant things that JavaScript on questionably trusted sites could do. So yeah, I guess any other questions about resolve.conf and hosts? Nope, okay. So if you popped up in your VM and were like, I wonder what host says about google.com, you'll notice that it has a bunch of different addresses, and it's like, what? There's only one Google. If Google sets records to say google.com is this address for a bunch of different addresses, it's a form of really naive load balancing in that when you have multiple IPs bound, they'll return in a random order. So if 10 different people hit google.com at the exact same time, odds are that they won't all end up on the server. Not a big deal if you've got 10 people, but if you've got 10,000 or 10 million all at once, this can be the difference between your servers falling over and staying up. Also, if they have a short time to live and you have negative caching, then if one of the servers does fall over, things will realize rapidly, oh, this IP isn't in rotation anymore, and they'll return you the IP of one of the ones that is working. So the way DNS handles all this magic, the way that you tell it, hey, google.com does have this address and also does have that address, are with different types of records. So an A record is just this name goes with this address in the IPv4 system. A quad A is this name goes with this IPv6 address. A CNAME says you should actually go get the record for this other name when you look up the first name. A pointer record points to a name, returns the name, and rather than returning the IP for that name or looking it up like a CNAME would say to, it just stops. This is useful in reverse DNS, which I'll get to in a minute. Other records you might see around are SOA, Start of Authority for a zone, because each of those nodes on the tree that I showed you, like .org, osusl.org, whatever, are zones. They should have administrator contact info, serial numbers, timers like time to lives, just assorted information that a system might need. And then email is all routed via MX records. So if you use the command dig and then a host name, it will give you a bunch of stuff, including the email. If you use dig space MX and then the host name, that will tell you just about how the mail is routed for it, which can be really helpful if you're getting email bounces or if you're not sure how something is working. It's a very valuable troubleshooting tool. So this reverse DNS stuff, this is the reason that we care about pointer records. Usually when people are setting things up, nothing really obligates them to set them up this way, but they'll often do it because it makes things easier for everyone else. They'll add pointer records for the locations. So when you get the IP out of a host lookup, you have these 4 separate segments. And then if you look up those 4 segments, instead of first, second, third, fourth, third, second, first, and then append that in adder.arpa, you can look that up and it will follow each thing. It's like climbing back up the tree rather than going down it. And this will tell you the host or name server that's handling that particular IP address. So this is a convenient way of seeing which host names are associated with whom, what's being managed by whom, and so forth. Okay, questions on DNS topics? Yeah?
So if it all goes to one server at the top that hosts this, how does your computer know how to get to that one at the top to get the very first one? And what happens if that server fails or something? How do they
So the reason we don't use recursive DNS all over the place is exactly in case root were to fail. Because if we used exclusively recursive instead of caching DNS, then every single query anywhere would have to go through that root name server, and that makes a single point of failure, and that's just bad. So you use it because in, I'll scroll way back here, in resolve.conf, it's like, here, you should use these for your name servers. If it has cache, like, oh, the .org name server is over at such and such a place, then it will try from that cache before it goes on and looks up something else, looks up a name server that it knows and so forth. Does that kind of answer your question? Yeah. Anything else? Yes.
So when you post google.com, it gives you those 10 ideas.
Yeah.
You said it was kind of crude. What's a better way to handle that? Or is there like a reasonable that way to handle it?
You could, that's the best way of load balancing your DNS. You could have a single IP that is round robin to several different hosts on the back end, so that whenever a hit to google.com comes in through Google's network, it then gets directed. A hit to that IP gets directed by a load balancer to any of a number of different servers, depending on which one is most available, or whether it was a cache hit or miss. Like you, just as a matter of principle, you should be caching as much stuff as you possibly can to begin with if you're in a high load situation. So if there's a single IP that's being served by 4 or 5 hosts, let's say, then your query will come in. That IP will be on the load balancer, really. That will look at, oh, what do they want from me? Do I have that cached? Nope, I don't have that cached. Okay, which host can I send this on to who currently has capacity to handle it? And then sends it on, and then gets it back out to the load balancer, caches that information if it's appropriate to cache it, and then sends it back out to you.
No other questions? Hi, I'm Ken. I'm going to make you all into Apache web server administrators. I've only got an hour and a half to do it, so some of this might go by kind of fast. So if you've got your laptop and your VM, it'd be a good idea to spin that up, because we're going to play with that a little bit.
Shall I spin up the VM on here?
I don't think I need. I'll
Okay.
just
That's
we'll
cool.
talk about it. They'll do all the work. We're just gonna present it.
Good idea.
All right, so if you recall from earlier sessions, we created a little web app called System View using the Flask Python framework, and we tested it by running its built-in web server on the command line. If you remember, you went into your VM and you said run server, or I forget what the command was exactly, and then you had to go to a special port to talk to your VM so that you could see it. We would like to install a real production quality web server on a standard port and start our web app using that web server. We would also like to party. That will come later. So why do we want to do that? Because Flask's built-in web server is not robust or secure. It's very, very tempting when you build your little Python app to just use the built-in command line web server, and then it's a very bad idea. It's not designed to handle multiple requests. It's not designed to stand up to a lot of traffic. We want to use standard ports for our web app. We don't want to have to go to :8080 to get to our application. We want to just go straight to the VM on the standard HTTP port. What is the standard HTTP port? 80, port 80. Remember that. That's a good thing to remember. And we might want to have many different apps on the same server. That's a pain in the butt to do if you have to start them all from the command line. And where web server administration is cool. So a little bit of review. What is a web server? We're talking about this thing right here, which is software. We're not talking about the machine. We're not talking about the computer. We're talking about software. And what do web servers do? I want to be a little painstaking. A lot of this is going to be review for you guys, but I want to make sure I'm really clear about the terminology. The web server is a piece of software for talking HTTP, Hypertext Transfer Protocol. That's all it does. The server does not run code, sort of, kind of does. It's not supposed to. All that code, the PHP, the Ruby, the Python, those things run through their own separate interpreters. The web server is just there to pass the data on to the web browsers and other clients that connect to it. So when you think web server, think something that's just getting data from somewhere, an application, or a file off the disk and handing it to your browser. It's not calculating, it's not running code, except kind of when you talk about Apache and modules. So Apache runs all this code and talks to these other interpreters using modules, and often those modules will run the code within Apache's own process. So web server is kind of running the code, but it's doing it through this extra module that's plugged in. But it uses the same process and has a lot of the same problems. And that's a whole different topic and subject we'll get to. But before I go too far into setting up a web server, I want to talk a little bit about AJAX, JSON, and APIs. So does anyone know, you've heard AJAX before, right? Anyone know what that stands for? Asynchronous JavaScript and XML. Very ugly, well, most things having to do with XML for some reason have ugly acronyms.
Excellent fits in still.
X is good. You'd think they'd get better. Well, AJAX is pretty nice. It's just not nice if you have to say it out. So browsers render HTML and CSS. This is another one of those distinction things. Browsers run one kind of code. They run JavaScript. In theory, some browsers might run other kinds of code, and Google and Mozilla are both coming up with different sorts of in-browser code running things. But the standard right now is JavaScript. A browser can handle HTML, CSS, and JavaScript. It does not run PHP. It does not run Python. It does not run Ruby. Or if you remember, all that happens somewhere else behind the web server. So JavaScript is often maligned, but it's very useful. It can dynamically update the layout of your page. It can handle user interaction when you click on things and move things around. It can call back to the server to get more data, and it can process that data. It's client-side logic. Anything that happens that requires logic or calculating or doing something like that in your browser is done by the JavaScript. And by the way, that calling back to the server for more data, that's AJAX. So an HTTP request is initiated by JavaScript. This tends to happen in the background. You don't realize it's happening while you're looking at the web page. The code is running in your browser, whether you're aware of it or not, and it decides that it needs to update something, refreshing a list of tweets on your page, something like that. It calls the server and says, hey, send me more data. The JavaScript then listens for that data to come back in an asynchronous way. It sends off the request. It's the asynchronous part. And when it gets the data, it processes it. Maybe it updates a div on your HTML page, something like that. Traditionally, AJAX, as you can tell from the acronym, used XML. Most of this kind of data is moving to JSON now, which is the JavaScript object notation. So this is what JSON looks like. It's fairly easy to read and follow for a given value of easy. You can see that it's nested. It has a top-level item. It looks like it's like a Python dictionary. Colons, brackets. You can nest things. Things can have a value, and multiple things in the list.
JSON object.
Yep, that's one JSON object. And pretty much every programming language handles JSON pretty well now. They all have a library where you say something like JSON import or JSON loads, and you'll get an object in that language's native, format. It'll be a dictionary or something like that. Easy to work with, pretty nice. This is XML. This is the same thing. These two describe the same object. XML is tag-based. Does this look kind of vaguely familiar? Does this look like something else you might have used as well? We'll talk about that a little bit. Again, it's nested. All the same data is there, but it uses, instead of brackets and colons and lists, everything is enclosed in tags. APIs is another piece of this whole web app sort of ecosystem. So when a web app talks to another web app, when JavaScript from your browser talks to a web app, or when your command line, you run a program like curl that talks to a web app, they talk HTTP, remember, because that's all your web server knows how to do. And it uses clearly defined HTTP commands like get or post. The API is sort of a document and sort of code. The document part is where somebody like Twitter writes a description of what all those parameters that get in the posts and the URLs are to allow you to talk to Twitter and get data back. That's the document part. The software part is on their side where they actually implement all those URLs. So when you go to that URL with those parameters, you get the data back that you look for. So if you've got a command line open, you might give this a try. Call, let's see here. Where's your terminal? I'll post this into IRC for you.
Alt-Tab or Meta 1 window.
So this is Facebook's graph. What do you get? What happens? And you can just copy and paste this right out of the IRC channel if you want.
Got there.
You got an error. What?
Well, it's JSON object.
Yes, you got a JSON object.
I didn't get an error. I got a JSON object that contains an error.
This is an important thing about APIs. A well-defined API, a correct API, will not just die on you. It'll give you an object in the format that you expect. If you call a JSON API, it should give you a JSON object back. Even if that JSON object says, you don't have permission to do this, go away. So here's another one. This is a GitHub API. Try that one out.
What is this URL?
That is a command line HTTP grabber. It's something URL. I forget what the C stands for. Maybe command line?
What curl does is it takes whatever thing is at that location and attempts to download it into whatever folder you're currently in, unless you give it some other instruction about where to put it.
Yep.
Curl is one of those things that just gets baked into your hands to the point you don't even think about it anymore.
So when you do that, you should get a bunch of stuff. Yep. So you got a JSON object, if I recall correctly, with all of the OSL repos that we have available on GitHub. This last one is slightly different. See if you can spot the difference. Oops. No. Come on.
So while you're trying to get that, Wikipedia doesn't seem to explicitly say what the C stands for, but it does say that it was written in C. So
It's probably
C.
I mean, URL is the uniform resource locator that you give to curl. So.
Yeah. There are other things like this. There's a command called wget, which gets from the web, wget. Oh.
So I got a dialog to download a file.
From the command line?
I just clicked it from my
Oh, you see, this is the thing. If you go to one of these in your browser thinks it's getting data that it's supposed to render or do something with. Different browsers deal with these things in different ways. If you go to an RSS feed, which is just another kind of text data, a structured XML file, your browser will think, oh, this is an XML feed, I should open up a feed reader, or I should display this as if you're trying to look at the RSS feed. We use curl because we can see directly on the command line exactly what the server is sending back without the browser trying to interpret things for us. So what did you get? XML. A lot of APIs still use XML. It's prettier until you have to do complicated things with it.
Yeah.
Yes.
Yeah.
Yeah.
I don't know.
Okay, so now we have, we know about APIs, we know about JSON, we know about AJAX. Let's install a web server. We all have your VMs open? It's a pretty simple command, yum install httpd, which is hard to say quickly. It shouldn't take too terribly long. I'll give you all a few minutes. Get caught up. Is there any questions while we're waiting for these things to come up?
Is that still HTTP for Arch, or is this Apache too?
I don't know because I assumed this would be on your VMs, Bootcamp VMs, which are CentOS.
No, you want it
I'm not sure.
So where are the internet lazy to spin up for VMs? I can install a list of several of them.
It's Apache 2.
Apache 2.
Yeah.
Perfect, thank you.
Yeah, and Brian, I would try that for, I don't know what Arch's package name, but that's probably a good guess.
It's more money because all the directories.
Is this your bootcamp virtual machine or your regular?
Yeah.
You should be in the bootcamp.
Yeah, it's Apache 2.
There was no Apache 2.
Is it HTTP? It may just be Apache. I don't know. I don't use Arch, so.
Well, do you have your app installed on system? Or, let's go.
It's just Apache.
Okay. All right, how's it going? Do we have Apache installed? Approaching installed, getting close to installed. While that's running, what is Apache? HTTPD is the HTTP daemon, also known as Apache, which was born in 1995. How many people in this room were not yet born as of 1995? Okay, all right, just checking, because sometimes. All right, you don't need to tell me how old you were. I just want to make sure I haven't gotten too old. So it's old, it's solid, it's very tested, it's been in production all that time, it's been hit with everything. It's a tank. It's old, complex, and slow. It's not really all that slow, especially if you are a very good administrator and know how to tune it and tune all the parameters and set it up in a way that it won't be slow. But out of the box, it's not the highest performing web server in the world. There are modules for practically everything. You can run Python, PHP, CGI scripts, Ruby, all kinds of things, and it does those through modules that plug in. As I mentioned earlier, most of these modules run the code in the Apache process, which is not great, but it works okay. So how are we with, does anyone not have their server installed yet? Everybody installed? Okay. All right, let's serve some web. The document root is the place where, or on the machine itself, where Apache will look to serve files from. So when you look at a URL, this slash right there, that's the document root. So when you go to this URL, Apache starts looking there for this file. So where is the document root on your machine? Let's take a look at config file. So if you're on your VM, your Apache config file will be here. If you installed it on a different operating system, probably there could be, etc. Apache conf, HTTP conf, various things. So find that file on your system and pop it open. We're not going to edit it right now. We're just going to look at it. If you do a search for document root, you will find that it points to this directory on your system. Brian, I don't know where it's going to point on Arch. Probably this. This is a pretty standard.
It wouldn't install, so.
Oh, okay.
Don't
So,
Can you try Yellow?
What?
Yellow is that.
Oh, no.
Okay. And then we also have an Ubuntu over here. It's not an XC Apache 2 or XC HTTP.
probably Apache 2 on Ubuntu.
Etsy, Apache 2, Apache 2 conf.
That's. By the way, welcome to supporting multiple distributions of Linux. They're all slightly different, but they all have things in common. Apache will always have this document root defined somewhere, and this block of code tells you what all the options are for that directory. You can move this wherever you want. You can put all your files in your home directory, you can put them in temp, you can put them in, wherever. I don't recommend doing that. Put them somewhere sensible. If you have a huge, complex website with lots of HTTP stuff in it, You might create a directory specifically for that and break it out in some really well-organized way. If you're installing system packages for web apps, like you want to install a webmail app or something like that on your system, they will tend to assume that this is where things go. So you have to be careful if you move things around. So anyway, you'll see lots of stuff in that config file. This is the only stuff that's important to us right now. But if you're bored later on, look through at all the different things you can configure right out of the box for Apache. Okay. All right, let's write some HTML. Go to your document root, wherever that is, and open a file called index.html. You don't have to write exactly this in it. By the way, doesn't this look a lot like XML? Oops. That's because HTML is a subset of XML. So the important things for HTML are the HTML, the head, body, and a closing HTML. It's XML, so everything has to be in between tags. You have to close the tags. Turns out, if you just write plain text and you point your browser here, assuming that Apache got set up correctly, your browser will figure it out even if it's not correctly formatted HTML most of the time. Because your browser just renders whatever it's given. If it's got HTML in there, it'll do some work to format that HTML however it thinks it ought to. If it's just text, it'll just feed you the text. Yeah?
Why are we going to localhost 8080?
Because that should be, because on your Vagrant box, we're mapping 8080 to the virtual machine's port 80. So, yeah, so it's slightly misleading. We want it to be on a standard port. It is on a standard port as far as the VM is concerned, but you're still talking to the VM through this mapped port. You're not going to port 80 on your local host. And the Vagrant system kind of translates your local 8080. But trust me, on the VM, it's running on the standard port, I promise.
But if you did like a curl index, like localhost /index in the VM,
Yes, yes, exactly.
Retrieve the file.
Yes.
From 480.
Okay, where is everyone? Uh-oh, permission denied.
Yeah, that's fine. Okay, so yes. So we're at the part right here. Okay. So with permission, escape, colon, keep, colon, keep, colon, keep, bang.
Writing some HTML.
Right now, okay, let me show you something. How's it working? You go to your home book. If you say .apache2.com, then you go right here to apache2.com. And houses. If you want to add Apache's Apache2.com. There's the actual so, yeah.
So give me a wave when you have a HTML showing up in your browser, so I can get a sense of where people are.
If you wait for me, it's bigger.
I don't know. I'm not waiting for you.
So you told me to put in the comments, you have a slide with that right now? You're in the list. Slide should have something. budget is based on staffing. That is not what your file will look like. That is what your file will look like. Yeah. So you just copy that and then
Explanation.
at the end solution.
What are you guys doing?
Here's what let's do. Let's click up. We're making it go in and look into the end.
Okay. You shouldn't have to do anything with the config file.
So what we're going to do is we're going to move the default button.
Now, since we're in this HTTP directory, that is, it has permissions for the web server, and you're not the web server, so you have to suit the connection.
That's called
How's it going?
Yeah, now you have your Apache.com. I mean, if we have to actually start Apache,
You should start for you when it installs the package, but if not, I don't know about Ubuntu. Maybe it doesn't.
I don't know.
Don't you have to do check config for CentOS?
Did you write your HTML in the location that we were told to? So it's variable.html. The directory may or may not exist, so you'll have to see if it exists first. Try and see the directory.
It's not actually really just go. Grab your Apache process. I think it's not Apache. Or, but yeah. You can, so to try, so HTTP site. So it's not right now, so we'll have to replace that as a start. Yeah.
All right. So is everyone serving their own HTML now? More or less, getting there? Okay. We are at sort of the halfway point. We're at the halfway point of the night, so if you guys want to take a few extra minutes to get all up to speed, we can do that, or if not, we can just charge on. So who wants to just charge on? Okay. Who doesn't? Oh. 2-0, good enough. Okay, so what's happening? Apache is receiving a request for the file index.html. It translates that slash into var www.html using the document root directive in the config file. It looks in that directory for the file index.html. It finds your file and sends its content along with HTTP headers back to your browser. Those headers are important. We're not going to go too much into depth, but those are the things that tell the browser what kind of content it's receiving. But you want to run code. So let's create a new file called index.php and put a little bit of PHP code in it. Don't put this in your index.html. Put it in a file called .php. You can just copy your HTML file to one called index.php and edit it and add, this is the only major difference right there, adding PHP code. So what did you get? Anybody there yet?
Well, I'm not there, but I'm assuming that you just did a blank page with the title. This is only a text. It's my guess. But I don't know if PHP is installed on the I mean, what?
Hey, Justin, could you close the door? The piano is distracting. So what did you get? Anything? Anybody? White page. Yeah. Apache doesn't know what PHP is. As I said several times before, the web server does not run code. It needs a module to run that PHP code. So the next thing we need to do is install PHP. It should be, I think the package name is the same everywhere, so you should be able to install PHP in whatever platform you're on. So, did you get it set up?
Yeah, it's more or less working. You'll have to look in the slides to grab the correct one. It won't have the
Yes.
So when Apache renders PHP, does it store it in a text file somewhere with like a catch? Or is it?
No, so you got a blank page on yours? Or,
Yeah.
okay, so when I tested this, I got just this text, question marks and everything. Normally, your browser, it's text. It doesn't know. It just, oh, here's some text. I'll display this to the user. Because PHP code, if you recall, doesn't run in the browser, doesn't run on the server. It needs something to interpret that code. And since nothing interpreted the code, you just got the code. And the browser, not knowing what else to do with it, displayed it.
So it did see the angle brackets as a tag, the HTML tag?
It might have. Like I said, when I did this, I got the text with the brackets. Your browser may vary. You may have gotten a blank page with nothing. Or if you had a typo in there. So once you install PHP, you'll need to restart the web server. So that's service httpd restart, or Apache, whatever it was you installed.
You might need the sudo.
Oh yeah, I probably glossed over this, but you guys have been in boot camp for a while, and you should know this already. When you're doing system kind of stuff, you usually have to sudo, because you don't have permissions to do things. Yes?
So just to point out, on a production system, Apache would have its own user. The files that you're serving with it would need to be of a user or group that allows Apache to access them. And then this way also, even if someone gets into your Apache process and can access the Apache process, they can't find things elsewhere on your system.
Yeah.
So you check the file permissions in your var folder, whatever your site name is, and make sure that Apache can read them.
Yeah. Typically, when you go in and start editing files, they'll be read everybody. There'll be a 644 soup, so Apache will be able to read them. but it's very easy to put things in a directory that Apache doesn't have access to. If you look through the config file, you'll see that Apache explicitly says what its user and group are, and in the case of CentOS, it's Apache for both. Are we ready to move on? Have we got PHP installed? All right, now load your file again after you've restarted HTTP. Oh, I didn't do that yet. And you should get a little thing that says, "Hey, this is PHP." All right, so looking at the configuration directory, now this is going to vary on platforms, but on your CentOS Vagrant box, there's a directory under etc. HTTPD called conf.d. And if you're bored and look through that gigantic Apache configuration file, you'll see a line that says load basically conf.d asterisk. Everything under conf.d, load those as extra configuration files. When you install the PHP package, it put its own PHP configuration file in there. And basically all that does is it checks, whether you're in pre-fork mode or worker mode, which you don't need to worry about right now. And depending on what the case is, it loads the PHP 5 module. So now Apache can execute PHP code. It adds a handler that says if you run across a file that's .php, that's PHP code, have PHP interpret that file and send the results back to me. This is a interesting text.html.php. It says if you have a .php file, we're going to treat it as a text HTML. This is kind of a confusing way that Apache figures out what kind of data it's getting back from the rendered file from the PHP module. And it confuses me too, so I'm not going to try to explain it. But PHP puts this in by default, and it's safe. You could have any extension here you wanted. You could tell Apache to send all your HTML files to PHP. You could tell it to send your Ruby files through PHP. PHP would be very confused and send back errors. But you're allowed to do that. You're allowed to set up any kind of file extension and send it to any kind of interpreter you want. And this file here says if you run across something called index.php, treat that as the index. Load it by default. If someone goes to the doc root just to slash and doesn't put a file name in there, load index.php. The main Apache configuration also has one of these that says index.html. So if you have both in your directory, Apache will decide which one to take first. I believe it will default to HTML first. So if you have two indexes in your directory and you're getting the wrong file, check to make sure that Apache knows which one to load as the index. Or better yet, don't have two indexes in your directory. Okay, but what we want to do is we want to serve Python. We don't want to deal with PHP. Everyone hates PHP. Very few people can articulate exactly why they hate PHP, but everyone hates it for some reason or another. We want to use Python, and Python has a module for Apache. It has two modules, probably more, but two that I know of. There's ModWSGI and ModPython. ModPython is a lot like ModPHP. It will allow you to write Python code in a file and just have Apache serve it up and interpret it and send you the results. WSGI is a little more sophisticated, web server gateway interface. What this does, it's a standardized sort of socket to plug Python code into a web server. So any web server that can understand WSGI, any web app that can speak WSGI, you can plug them together. It could be Apache, it could be light HTTPD. Wow, these server names are hard to say. It could be Nginx, it could be any number of things. As long as you have a standards compliant WSGI app, you can plug it in pretty much anywhere, regardless of how that web server handles, the Python code. And it allows, I mentioned earlier that many modules for Apache will run within Apache's process. So if you do that PS command and you see Apache running, that Apache process that you see listed there might be running PHP code or other kinds of code. WSGI allows you to have an interpreter that's completely separate from the web server. It can be a completely different piece of software, completely different application that's running beside your web server that your web server can talk to over this standardized socket, which is very nice. All right, so we have to install more stuff, unfortunately. So now we're going to install the mod WSGI module. And after you get that installed, or while it's busy installing, we're going to check out our system view application that we created earlier in the boot camp. And we're going to put it somewhere convenient. Let's say var www. And by the way, after you've checked this out, you go into the system view directory and then check out the WSGI branch, because we've created a special branch that has a WSGI defined. So you're administering an industrial strength web server. Do you feel powerful? Yeah, give me a wave when you've got the repo checked out. All right, don't forget your virtual env. This is a lot of review of stuff we did many, many weeks ago. So without going into detail, you can just copy these commands. Create a virtual environment. You can create it wherever you want, but create it in VNV, in the current directory, or in the system view directory, sorry. And then activate that virtual environment, and then install the requirements.
Does the VM have Apache using
Yes, Apache is the default Apache user.
it? So when that installs,
Yep, when you installed Apache, it installed an Apache user and an Apache group. And after pip is done installing things, it shouldn't take too terribly long, we want to change the ownership of the whole system view directory. So who can tell me what this does precisely? Let's review basic Unix. You should know this. Yes?
It recursively steps through the directory and changes the user from whatever it is to Apache.
Exactly. What if I'd put Apache :Apache right here?
We would also run ch group to change the group to.
Okay. So once you've got this installed and pip is finished and everything is owned by Apache, so that Apache doesn't have any problem reading it. Actually, left off a step. You need to restart Apache. So service httpd restart. All right, I want to talk a little bit about what makes an application WSGI. This is the file that I added to our system view application that turns it from just a standard Python Flask application into a WSGI enabled application. There's not much to it. It's pretty simple. This line activates our virtual environment. And when you created your virtual environment, make sure that you created it here or edit this file to point to where you did create it. It defines what that activate this is, then it executes activate this. It imports system so that it can find, so that it has the path method, so that it can insert this path into the Python path, so that Python now, in this context, knows where to find system view. And then it imports the system view application with the special name application. WSGI likes to look for application. WSGI assumes that application is the name of your application, so no matter what you've called your application, you have to alias it as application here, and then WSGI can find it. Yes?
So we ran a virtual from the command line and used bin activate. Why do we use this one now?
This is basically what bin activate does. This is more friendly to, I'm not sure exactly how to
We
explain.
don't want to shell out
Yeah.
an arbitrary shell script, since this is Python.
Yeah,
right
so,
here.
yeah,
So this .WSGI can be imported by Python and run as Python, and it's pure Python right all the way
Right.
through, rather than shelling out to bash that you don't necessarily trust that somebody might have stuck malicious bash in there.
yes. Excellent. Good description. Activate is a bash script. This is a Python script. Right. That's all you need to do. Add that file that points to all the correct places for your application, and you have a WSGI app. Oh, but we still have more configuration to do. We have to tell Apache about system view. So this is a block, and I included this in the repo. So you can open the file in the repo. It's in docs systemview.conf. You can just create a file called systemview.conf in that etc. httpd conf.d systemview.conf. And remember, everything in that directory gets loaded into the Apache configuration, just gets appended to the end. Just copy paste that stuff right in there. And then Apache will know that this is where it should look for a WSGI socket. This is the name of the app, or the process that it's going to use. It's going to use user Apache, group Apache, and it's going to use 5 threads. We don't need to worry about that in this application, but when you're deploying real production web apps, you want to be conscious of how many threads and processes you're using. It's then going to create an alias. This is whenever you go to /systemview, it's going to go to this WSGI file. So it's not going to rely on Apache's doc root and just look for the file on the disk. It's going to specifically say, if you're looking for system view, load the WSGI file, load this WSGI app. And then we set up a directory. We say, in this directory, use this WSGI process group, application group. None of this stuff is important to worry about right now. It's pretty standard. It has to do with what Apache calls applications and processes. I'm going to say set up some permissions. Basically, we're going to allow everybody to connect to this. And once you have this file in this location, of course, you have to restart Apache again. Yes?
What do we, in the other one, there was order allow, deny. Why did we go deny allow?
So what this is saying is, it's whether or not you start off by denying everything and then allowing specific things through, or whether you just allow everything and then deny specific things.
Whitelist versus blacklist, basically.
Yeah, and this
Just
just
users or files, or what is it allowing?
It's allowing options, which we don't have any of in here. There are a lot of different things that you can allow to happen in a web directory, and this is a whole other discussion. But if you're talking plain old HTML and you're serving a plain old web page, you can have a file called AJAX, which has additional configuration things in it. You can tell the main Apache file, say, okay, allow them to set whatever they want in AJAX, except don't let them set change the directory index. I'm not entirely sure, because I don't use Apache ModWSGI, what specific options this is applying to. But this is sort of the default configuration that they hand out when they say, here's how to set up a WSGI app. And we don't have to go into too much detail right now. So once you've got this installed and your Apache is restarted.
Restart or reload?
Well, that's a good question. So you can restart a service on a Unix machine, which means stop this service, shut it completely down, then start it back up again. Or you can do a thing called a reload, and different services have different ways of doing things. Apache has a reload, which says don't shut Apache all the way down, just reload your config files. There are other services that allow you to do this, not all of them. You can also talk to Apache not through service. There's a utility called Apache CTL. It comes with the Apache package, and it allows you to do all kinds of things to the server. Reload it, kill it, dump stats about it, things like that. Yes?
So one fun fact about Apache's reload is that before it takes Apache down, it will run through and try to make sure it's going to be able to come back up successfully. Like, if there's a blatant configuration error or something, then it won't take it down at all because it knows it wouldn't be able to get back up. This is great until you run into errors that are sufficiently subtle that it doesn't catch them and it goes down anyway if you didn't think it would. So never completely trust it.
Yep. All right, so once ModPython is installed, the repo is checked out, it's owned by the correct person, Apache is set up to serve that application, Apache is restarted, you should be able to go here and see the system view app. Yes?
So if you wanted to host it out of the root directory, that'd just be changing the document root in the main Apache file, right?
No. Let me go back here a little ways. Where is it? See this this script alias? That says take that /system view and point it to this directory. This directory can be anywhere whatsoever. This completely short circuits doc root altogether.
Okay, so doc root doesn't matter.
That doesn't matter. Apache explicitly looks for this file or this string in the URL, and if it sees it, then it goes to that WSGI file.
So if you wanted to serve it out of the root, you just have a / there?
Out of the root of the machine? Yeah, you could do that. That's crazy. Don't do that. People put apps in a lot of different places. Some people serve them out of opt, some user local. /srv is a pretty common paradigm to do things. You put all server stuff in /srv, you know, your FTP server directories, your HTTP stuff, your apps. Some people put them in var lib Python or var lib Flask, depending on the thing. So I don't think there's any really industry-wide consistent place to put applications. They all kind of go wherever that particular system administrator feels like they ought to go, which can be horribly confusing, but now you know where to look to figure out where things are located, right? Where do you look to find out where your application is living? What file do you look in to figure out where Apache is looking for your application? Somebody, come on. All right.
Apache conf file.
Yep. So actually, we went through this much quicker than I expected, and that's basically all that I have. If you have questions or things you want to work on, or we can dive into this in a little more depth, we can go to System View's master branch, which has the database code that we worked on before installed. So you'll need to set up a MySQL, and you can get your web application working with MySQL. We can talk a little bit about virtual hosts, or we can talk about other web servers, such as Nginx. So what would people like to talk about? First of all, any questions? Any specific things you want to ask about or talk about? Yes?
Kind of a follow-up to my last one. So, like, what I was thinking is, like, if you type a URL in there, you usually don't have to know what's beyond it. It just redirects you there. So how would you set up a redirect to take you to the right spot? So just localhost 8080, you don't put anything past there, redirect me to system/.
Yeah, you would just tell, that would be an Apache directive. You would go into Apache and you would set up a directory, the / directory. Let's see, I think it's... Yep, so you would go, you would set up not a directory, you would, thought I had an example. You would set up a redirect. You would just tell Apache explicitly, when someone asks for /, point them to /system view instead. I'm sorry, I thought I had more code there, but I guess not. Any other questions, topics? Did everyone get System View app running in their Apache? Who was trying to?
I'm gonna look that later.
Okay.
I wanted to ask, like Nginx and WebRick,
Mm-hmm.
what are the key differences with others?
Okay. WebRick is one of those sort of built-in lightweight command line kind of run a web server for this particular code. It's very unsophisticated. It just kind of serves whatever's there. It doesn't have all the configuration options. It's not very secure or robust. It's a development web server. It's a web server for when you're working on your code and you make a change and you want to look in your web page and see if you broke anything before you push anything onto a production system. Nginx is fairly new compared to Apache. As I mentioned before, Apache is gigantic and ancient and is seen as slow. Nginx was meant to be super simple, and very specifically, Nginx was designed to have a front-end HTTP server that was really fast and really good at passing requests off to other software. So when you use Nginx, it doesn't have a WSGI module. You just tell it to point to your WSGI server, which is another piece of software. Typically in OSL, we're using uWSGI, which is its own standalone WSGI server. All it does is talk WSGI. And Nginx, all it does is talk HTTP. And it gets an HTTP request for a WSGI app. It just goes, points it directly to the socket and lets you WSGI handle all the requests and returning the data. Nginx can be very fast. It's very good for putting one web server up front with lots of web servers behind it so that it can pass traffic to the most available server to load balance everything out and make things high availability. And it's very nice. It's much, much simpler to configure. The gigantic HTTPD conf file that we looked at, Nginx's default config file is a tenth of that. It's much easier to set up. There are other lightweight, light HTTP is another common one that's pretty popular. It's also just meant to be bare bones, basic, serve up web pages, don't do anything else fancy. Apache is still really good for doing big, complicated things where you need lots of routing and redirecting and rewriting. Apache is really good at things like I'm going to rewrite every piece of data from this location in this specific way and change all the paths and hand it off, stuff like that, which is not a typical use case, but it's handy sometimes. Any other questions, topics? All right, so do we want to dive into installing System View and MySQL onto our existing Apache, or do we want to talk about virtual hosts, which kind of ties into the DNS talk we had earlier? Thoughts? Anybody care?
I want to learn about virtual hosts.
Okay. So, a while back we were talking about DNS, and I'm going to go back and see if I can find an appropriate slide to talk about this. Yeah, so DNS maps a name to an IP address. Your machine has an IP address. DNS, let me step back. Your machine inherently has an IP address as soon as it connects to a network. It's part of the IP stack, it's part of the kernel. It's built in, it has an IP address.
That's what Erdan talked about on Thomas networking.
Yeah. DNS gives your machine a name. Your machine doesn't inherently have a name. A server or service protocol gives your machine a name by mapping its number to a name. When you go to Google or something like that, you don't want to have to type in an IP address. You rely on the service to translate your name into whatever IP address Google wants to hand you when you look for that name. A machine can have one IP address. It can have many names. You can assign lots and lots of names to a server, and this is very, very common. Somehow, that server has to know that you came there looking for /system, or for example.com/system view, not bob.com, some other system view. The way it does that is it looks at the host name that you were requesting. So your machine is listening on this IP address. It gets an HTTP request on that IP address. It says, oh, this is coming on port 80, hand it to the web server, Apache or Nginx. Nginx or Apache looks at that request and says, oh, looking at the headers, the HTTP headers, I see that this person was looking for example.com. What do I do with example.com? I want to look in my virtual host definitions, and somewhere in there, there's a thing that looks just like a configuration file, like the main configuration file, except it says, for this host, example.com, here's the document root, here are the options, here is the WSGI socket, because it's a WSGI app, and we're just going to point it there. And so that's how your machine knows what name you're looking for as opposed to what IP address. Different web servers set up virtual hosts slightly differently. It's not, it's usually pretty straightforward to understand. You have to read the docs for your particular web server. But it's a very, very powerful system. It allows you to assign any particular name. You can even have wildcard vhosts. You can have vhosts that's anything.example.com, send it over here. Vhosts are sort of the web server end of that CNAME idea, where you can assign multiple names to the same thing. The machine can respond to those different names because DNS points those names to the machine, but the web server software itself can respond because it looks at the HTTP headers. And there are several things that need to be set up to make this work. You have to have the correct DNS records, you have to have everything mapped in your vhost files and things like that. Is that enough detail? You have specific questions?
So in the hierarchy, you have a virtual host, and then inside the virtual host, there's like another config.
Actually,
the content of a virtual host will look a lot like what he had in, if you could scroll to where you have the Apache config.
yeah, I'm looking for it.
There we go.
Yeah.
You can have, this is a file, you can have several different directories and different sets of permissions, and you'll have a server name or server alias directive saying, basically, if I got in a request that was for such and such a site, then these things are going to apply. Then these directories are relevant to it, like var /w site name / document root or HT access or whatever your, whatever it happens to be living at. So this way, you could say, like, if I have systemview.example.com, I'm going to start from this version of system view, but example.com/system view is going to get that version because we're special that way.
Any other questions? Virtual hosts? We will eventually get to virtual hosts. It's kind of a pain in the butt to set them up for your virtual machine because you don't have a DNS server telling you what your virtual machine's IP address maps to what name. So you have to do that manually. How would you do that manually? How would you set on your local machine something that said pointexample.com at my virtual machine's IP address? Yes, you're answering all the questions. I'm sure somebody else knows. Does anybody else know the answer to this question? Yes?
I'm going to guess that we would push magic buttons in the vagrant file because that's how we forwarded our ports.
No, all we want to do is say example.com goes to the IP address of our virtual machine. How do we set
What did we talk about in DNS that correlates names to IPs? We could cheat and scroll through the slides.
No, do you remember?
You have to sign up for a dynamic DNS.
No. You're thinking.
Oh, scroll back through the slides, and this will jog someone's memory. Which of these things? Yes, there you go, Brian.
Well, I was waiting for
Or the host is right after resolve.
Okay, there, yeah. So here we go. We find out what the IP address of our virtual machine is. We put a line with that IP address and the name we want to give that virtual host, or that vhost. Then, on your local machine, nowhere else in the world, only right there on your local machine, when you go to your browser and you go to that domain name, it will look at your virtual machine. In our case, we would still have to put the port number on there. That's okay.
This will be the hosts file of the host system, not
Yes.
of the VM.
Yeah.
That's a potential spot for it to use. And if your host system is a Windows box, then they have a host file equivalent. Google it.
Yeah, it's a little more.
It's called hosts.
It's actually a folder called Etsy, I believe.
Really?
Your system 32.
Interesting.
System 32 Etsy host. Okay.
It's Etsy host or driver host. It's just hosts. It's not just.
You Google it.
Yeah.
That's with all Windows problems. You Google it and hope for the best.
So we didn't go into vhost originally because we would have to have you set your host file, we would have to set up the virtual host in the virtual machine, and we would have to make sure all the ports were correct and everything. We can do that if you'd like, or we can just talk about it. Any other virtual hosts or DNS mapping kind of questions? All right, let's install System View with MySQL. So
should we do this all together, or should we break out and work around the room and end the broadcast here?
let's talk briefly about what that entails, and then we'll break off and we'll work on it, and we'll be around to answer any other questions. So if you recall, the System View branch that we created the database, we set it up so that it would store our queries. So we would search the PS command for a specific command. It would give us some output, and it would save that search word that we looked for. So the next time we came back, we would see it, and we would just click on it. We wouldn't have to type it. In order to do that, we needed to install MySQL, and then we needed to set up a database on the MySQL server. And then we needed to set up a user on the MySQL server, that app, and a user and a password for that app to use to access its database. And then, if I recall correctly, we actually, did we create tables manually, or did we have a script for that? Yeah, I think there's a script in the repo that will create the tables for you. Once we have the System View app set up and the database set up, we need to add a WSGI file because I may have checked the WSGI file into the master branch, but I didn't mean to, so probably you will have to go into the master branch and create a WSGI file based on the one that's in the WSGI branch that we were working with earlier. And then once you do that, you will restart Apache. You really don't have to restart Apache. You probably should, though. Some things about the way WSGI works and Apache and mod WSGI. When you restarted Apache the last time, it read that WSGI file and found everything, activated the virtual environment. Then when you went back in and you checked out a different branch, the files changed a little bit, and WSGI may or may not find everything correctly. WSGI kind of looks at your application, it loads your application, it imports your application as a Python module. So when you change what's in that thing that it imported, after it's imported, you probably won't see those changes. Different WSGI servers have different ways of handling files changing. If you're using the uWSGI server, you could tell it that whenever files change, just automatically reload and re-import. I don't think Apache mod WSGI will do that for you. All right, so we're clear on what we want to do? All right, I'll let Emily take over.